Section 4.2, constructing arithmetic or arithmetic sequences. So two ways of pronouncing that. You might pronounce it arithmetic or you might pronounce it arithmetic, but whatever you want to do, it doesn't really matter. Okay, but what a arithmetic, I'll just say that for this time, sequences is it's a list of numbers, as we've talked about in section 4.1. It's a list of numbers, but in this case, the list is going up by addition, or it could be subtraction. I mean, technically, but basically you're adding a common amount every time. So for an example of an arithmetic sequence or an arithmetic sequence would be like 2, 5, 8, 11, 14, etc. Because you notice that each term here is going up by 3, right? We're adding 3 every time. So that's an arithmetic sequence when you're adding the same amount every single time. It wouldn't be an arithmetic sequence if you had 2, 7, 13, 21, etc. Because in this case, you'd be adding different amounts every time. Okay, you're still adding, but you're adding different amounts. So you can't really predict what the next term would be. So that would not be an arithmetic sequence. But it could be subtracting though. You could be like 2 and 1, 0, -1, -2, right? This could be an arithmetic sequence as well because you're subtracting a common amount. Basically, you're adding or subtracting the same amount every time. That's what an arithmetic sequence is. Okay, so that's what we're going to be talking about mostly in this video. Okay, so exploring them. So we have an example to start us off with, that you can order tickets to a movie online, and it's $2 per order. So basically, you go online and you pay $2 to order online, but each ticket costs $10. So the total cost in dollars of ordering N matinee tickets online can be found using the function there, C of N equals 10N plus 2. So basically, that's $10 per ticket, plus the $2 online order fee. So how much would it cost for 1, 2, 3, 4 tickets? Well, if you bought one ticket, it'd be $10 plus the $2 order fee, so your one ticket would cost $12. If you wanted 2 tickets, it'd be 10 times 2, which would be $20, plus the $2 online fee, which would be $22. If you wanted 3 tickets, it'd be 10 times 3, which is $30, plus the $2 order fee, which is $32. And then, of course, lastly, it would be $42. What is the domain of the sequence? So domain, again, is our x values. In this case, it's the number of tickets we buy. So 1, 2, 3, and 4. What is the range of the sequence? Well, the range is the y values, or the cost in this case. So 12, 22, 32, and 42. What is the first term of the sequence? Well, the first term is 12 because one ticket would cost $12. The first term would be 12. What is the difference between the 2 consecutive terms in the sequence? So finding the difference between our terms, you could just subtract one of the terms from its previous term. So, for example, you could take 22 and subtract 12 to find the difference between it. You could take 32, subtract 22, because that's the difference between it. And then you could take 42, subtract 32. So you take a number and then subtract the number that came prior to it to find the difference. So 22 minus 12 is 10. 32 minus 22 is 10. 42 minus 32 is 10. And I don't think it took a genius really to figure out that what the difference here is in our sequence is we're adding by 10 every time, right? 12, 22, 32, 42. It's clear that we're adding 10 every time. But this is a way of confirming it. Sometimes it's not that easy to do in our head, so we can just take the number subtracted to kind of confirm what the difference is. Now, these should all be the same number because remember, an arithmetic sequence, as we mentioned, is a sequence where you're adding by the same number every time. So in this case, adding 10 every time. Okay, so suppose you extend the table for up to 15 tickets. Would you expect the difference between consecutive terms to be the same? The answer is yes. We would expect it to be the same. It's always going to be increasing 10 because, it's always going to be $10 a ticket. Explain how the domain is limited in this situation. So domain is limited to only whole numbers. I'm not going to write this down, but I will just explain it. So you can write it in your notes if you have to. Domain is limited to only whole numbers because you can, or positive whole numbers, because you can only buy positive whole number tickets, right? You can't buy 3.5 tickets, for example. You can only buy whole number tickets. So your domain is limited, but it does go on forever. You could buy as many tickets as you want. You just would have to buy whole number tickets. Okay. So constructing rules for arithmetic sequences. So there are going to be two types of sequences or two types of writing a arithmetic sequence. And they're going to involve the same thing. They're going to involve knowing the first term and the common difference. So that's the main thing you want to know is what is the first term and common difference. That's hands down, those two are the biggest things that we need to remember. So common difference is that like 10 in the last example, which the number that you're increasing by every time. Like in the movie tickets, we were adding 10 every time because every ticket costs 10. That's the common difference, is the amount that's being added to our sequence every time. So we could write a recursive rule and an explicit rule for the same sequence. So looking at this first problem, we find that the first term is 2,000, right? The second term is 2,500. The third term is 3,000, right? Fourth term, 3,500. Fifth term, 4,000. So if you want to write the recursive rule, you simply follow this formula, okay? So for recursive, it's going to be f of n, which is just like your y equals, right? Equals f of n minus 1 plus d. Also, you have to give the fact that f of 1 equals something. So f of 1 equals something, and then you have your formula. So let me rewrite this so it's a little bit clearer. So when you write a recursive rule, you're going to have to write the first term first. F of 1 equals whatever the first term is. And then your actual function, f of n, equals f of n minus 1 plus d. F of n minus 1 means the previous term, and then d is your common difference. So you take the previous term, you add your common difference. So you'll see that in this example. Again, it's already written the recursive rule for us. It says f of 1 is 2,000 because you'll notice the first term is 2,000. And then it says its function, f of n equals f of n minus 1 plus 500. Now 500 is here because the common difference is 500. We're adding 500 every time. It's already noted that. So there is its rule. And you leave the f of n and the f of n minus 1 there because it's part of the function. It's just saying the term in the sequence equals the previous term plus 500. So you have to leave that there. So the only thing that you're going to be really filling in is the first term spot and the common difference spot. Like I said, those are the two things, right, that you're going to need to do and know the first term and common difference. Everything else is kind of already done for you. All right. And then, well, we didn't really talk about it much here, but you can also write this in the explicit rule. So the explicit rule, let me erase this and just write the explicit rule in its place so you could try to find room on your paper for it. Explicit rule follows a different form. Explicit rule follows f of n equals f of 1 plus d n minus 1. So again, there's only two things in this that you would have to fill out, which is the first term and the common difference. Everything else is part of the formula. F of n and n minus 1 stay as part of the formula. Now the n, in case you're wondering, the n represents the position of the term in the sequence. So an explicit rule, if you forgot from 4.1, explicit rule is where you can just plug in whatever position you want to find and it will get you that value. You don't have to find, like for example, if you want to find the 12th term, you just plug 12 in as n. You don't have to find the first 11 terms in order to get the 12th term using the explicit rule. Using the explicit rule, you could just plug in 12 into this function where n is, and you would get the 12th term of the sequence. So that's how explicit works. But again, so we're just going to leave the n there until we're asked to find a specific term. If it ever asks us to find the 12th term, that's when we'll plug in something like 12 for n. But in the meantime, all we're going to really focus on is writing the first term and the common difference. So you'll notice, based on this form, they have it written here. Their explicit rule, you'll notice f of n, just like our f of n. They've got the first term, which was 2,000, right? They mentioned that. They got the plus common difference. Our common difference was 500. We've got that. And then they have the n minus 1, like we have the n minus 1. So if you notice, all they really did, again, was plug in the first term and the common difference, which is exactly what you're going to be asked to do. So 2 forms, 2 rules to remember, the explicit rule and the recursive rule. So this one says write a recursive rule. So remember, our recursive rule means that we're going to have to write f of 1 equals, and then we're going to have to fill in that blank. And then we're writing f of n equals f of n minus 1 plus our common difference, which is fill in that blank. So we already have this much. Like, this is given to us. Like, you have to kind of just memorize this because it's always going to be written this way for the recursive rule. If it ever asks for the recursive rule, you're writing it exactly like this, and the only thing you're going to fill in is what the first term is and then what the common difference is. Everything else here is by default going to stay that way, okay? Because that's just the way the recursive rule is written. So the first term, right, f of 1 is 5,000. We see that. Our common difference is, well, it looks like we're going up by 1,000, so we're adding 1,000. So our recursive rule is f of 1 equals 5,000, right? That's here. Right, f of n equals f of n minus 1. You see it's already given to us, right? You see that part's already done for us. Plus the common differences is 1,000. So really all we had to do was fill in the 1,000 and the 5,000 to write that entire function. So the explicit rule, however, remember the explicit rule is a totally different formula. The explicit rule is f of n equals f of 1 plus d n minus 1. But again, you just need to know these 2 things. So the first term is 5,000. You'll notice that they've already written the rule for you. The first term is 5,000. They got that plus the common difference, which is 1,000. And they've already plugged in 1 for n. Because this used to be, you see where it says 0, it used to be n minus 1. But in this case, n was 1, so they plugged in 1 for n. And 1 minus 1 is how they got this 0 here. So essentially, we're actually plugging into our formula to actually find the second and the third and the whatever term. So f of n, this is kind of backwards. So you'd have 5,000 plus 1,000 times, because you're plugging in 2 to this one, it'd be 2 minus 1, which 2 minus 1 is 1, but that comes out to equal 6,000. And then if you want to find the third term, 5,000 plus 1,000 times 3 minus 1. 3 minus 1 is 2. So that's going to be 2,000 plus 5,000, which is 7,000. Right. So our explicit rule works for our function because you can see that we got the second term was 6,000, just like it says up here. The third term was 7,000, just like we got up here. So the function that we have here, it works. So d is always multiplied by a number equal to... generalize the results from trying to think of what d is always multiplied to. It's multiplied to n minus 1, which is always just the same thing as n, but 1 less than it. So yeah. Moving on, critique reasoning. Jerome says that the sequence 1, 8, 27, 64, 125 is not an arithmetic sequence. Is that correct? Explain. And if you remember, to make an arithmetic sequence or arithmetic sequence, I keep saying it differently, I'm sorry. It has to be adding the same amount every time. So you can see that 1 to 8 is plus 7, but 8 to 27 is definitely not plus 7, right? That's being added by a whole different number. So this is not an arithmetic sequence. I'll just say it rather than write it. It's not arithmetic because you're not adding by a common value every time, right? To get from 1 to 8 to 8 to 27 to 27 to 64, you'd have to be adding completely different values. So it's not arithmetic. An arithmetic sequence has a common difference of 3. If you know that the third term of the sequence is 15, how can you find the fourth term? So we know the common difference is 3. Let's spell this out here. So we know the third term is 15. How do we find the fourth term? Well, if we know the common difference is 3, right, then we know that we're adding 3 each time. So if I'm adding 3, then I would add 3 to this third term, and I'd get the fourth term, which would be 18. The common difference is adding 3, so the term right after it would have to be 3 more. So 3 more than 15 is 18. All right. So let's write a recursive rule and an explicit rule for number 5. So for recursive, remember recursive follows this form. F of 1 equals blank. We have to fill that in. Then f of n equals f of n minus 1 plus our common difference, blank. So everything's already done for us. Remember, all we have to do is just fill in the first term and then fill in the common difference. So in this case, the first term is 155. And our common difference is, it looks like we're subtracting 14. So it'll be plus negative 14, but instead of writing plus negative 14, I'll just write minus 14. And that will work. There's your recursive rule, just like that. The explicit rule follows this formula. F of n equals, remember, f of 1 plus d n minus 1. But remember, so we actually have to plug in our first term and plug in for d. So our first term, as we have already mentioned, is 155 plus the common difference. The common difference was a negative 14, so I'm actually going to make this a minus 14 and minus 1. So there's your explicit rule. So there's two different formulas for the same thing. I know it's kind of redundant, but there are two formulas for the same thing. It's a formula for the sequence, but one's written in the recursive way, one's written the explicit way. It's kind of weird that you have to know both, but I would honestly think that the explicit one, if you want to memorize anything, the explicit one is the way to go. The reason for that is because it'd be easier to find terms using the explicit formula. For example, if I ask you for the 30th term, all you got to do is plug 30 in for n, and you get the 30th term. With the recursive formula, you can't do that because you'd have to find the first 29 terms. You'd have to go all the way out till you can find the 30th term. So the explicit rule is a lot better for that because you could just plug in 30 and go, whereas the recursive, you can't just plug in 30 and go. It wouldn't work that way. So explicit's way better. All right. So it's got the formulas that we just talked about right up there, right? F of 1, f of n equals fn minus 1 plus d. And then we talked about f of n equals f of 1 plus d n minus 1. So I've already given you these formulas. We've already written them down, but here they are in your paper just in case you lose them, right, somewhere. So write a general recursive and general explicit rule for the arithmetic sequence. So you can see the problem that they give us. The first term is 100, and then they're subtracting 12 every time. Subtracting 12, subtracting 12, subtracting 12. So first term is 100. Common difference is negative 12 or minus 12. So their recursive rule, remember, f of 1 equals 100. They filled in this because they know the first term is 100. And then they filled in the common difference. Everything else was already supposed to be there. Remember, that's just part of the formula. All they're plugging in is the 100 and the minus 12 because 100 is the first term, minus 12 is the common difference. So let's do that in the explicit rule as well. The explicit rule is given to them, and they've filled in just two values as well. The first term and the common difference. That's all they had to do is fill in those numbers. But you have to know these formulas. You have to know them. So for part B to this, our first term, we'll notice, is 0. And the common difference is 8. Now, in order to get 8, you would have to take a term and subtract its previous. So you could take anything here and subtract the previous. So you could take 24, subtract 16. You could take 16, subtract 8, whatever. As long as you're taking a term and then subtracting the number before it. So let's do 24 minus 16, right? And that's 8. Either way, it's kind of obvious here that the common difference is 8. So the recursive rule, we need to know these two values. We need to know the first term is 0, the common difference is 8. So f of 1 equals 0. And then f of n equals f of n minus 1 plus 8. There you go. There's our function. There's our recursive rule. Now, our explicit rule, remember, we have f of 1 goes here, and then our common difference goes here. So f of 1 is 0 again, plus our common difference of 8 times n minus 1. So it's all filled in for you. All right. So number 6 asks us, write the recursive rule for this sequence. Now, this sequence is given to us in explicit form. But in order to write recursive, remember, we only need two things. We need to know what the first term is. We need to know what the common difference is. In this case, we can tell, because it's explicit, we can tell that we know that 2 is the f of 1. 2 is our first term. Negative 3 is the common difference. Because remember, that's how the explicit rules laid out. Explicit rules, f of n equals f of 1 plus, f of 1 plus d n minus 1. So f of 1 plus d. So if you look at this, we've got 2 is the f of 1 part, and then negative 3 is the d part. You got the n minus 1 at the end. So we know that 2 is f of 1, and negative 3 is our common difference. So the recursive rule would be f of 1 equals 2. We know that it's 2. We can see that it's 2. And then f of n equals f of n minus 1. Remember, this is all just based on the formula, plus the common difference. Common difference is negative 3. So plus negative 3, or if you want to just write, instead of plus negative 3, just write minus 3, then you're good. So that's all we had to do. So remember, this is all based on the recursive formula, and all I needed to know was 2 and the minus 3 to plug them in. And I was able to identify them from the explicit rule that was given. And then lastly, let's wrap this up with writing one more for 6, 16, 26, and 36. So the recursive rule, remember, follows the formula f of 1 equals something, right? And then f of n equals f of n minus 1 plus something. So our first term in the sequence here is 6. So we know that this first part, f of 1, is 6. And then the common difference is 10. It looks like everything's increasing by 10. So it would be plus 10 at the end. There's your recursive rule, just like that. Okay, it's all based on a formula. Like I said, if you're wondering, why is f of 1 here? Why is f of n equals f of n minus 1 there? Because it's part of the formula, right? Again, go up here. It's part of this formula, all right? If you want to find the explicit rule, again, explicit rule's formula is f of n equals f of 1 plus d n minus 1. But we're supposed to plug in f of 1. We're supposed to plug in d. And we know those things. F of 1, the first term is 6. And then d, the common difference we've already mentioned was 10. We plug in 10. There's your explicit rule. Again, it follows a formula where we just plug in those two values, the first term and the common difference. That's going to be it. I'll see you guys in section 4. I know there's more to this, but it's pretty much the same thing, just based on a word problem, though. So keep doing the same thing of finding the explicit rule and finding the first term and the common difference, and you'll be all set to go. I'll see you guys in the next one, section 4.3.